What that means is we know something is a right angle when one of the angles is labeled with a little box, which is over here. Okay, so we know Sohcahtoa, the acronym is SOHCAH and TOA. Who can tell me what the SO in Sohcahtoa stands for? Sine. Okay. So sine of whatever sine A is equal to opposite over the hypotenuse. And I'll tell you what that is after. The C stands for cosine. So cosine is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. So all of this depends on what angle we are using, but the hypotenuse is always going to be the longest side of the triangle. So it's going to be the one that's slanted. So the hypotenuse is always the slanted side. And it's easiest, and it's going to be the easiest to identify because there's only one slanted side on a right angle triangle.
Wait, what is
opposite? And I'll show you how to label each of those soon. So like I said, my hypotenuse is always the longest side of the triangle. So when we have a right angle triangle, what's the longest side? The slanted side. It's always the hypotenuse.
the longest side is the hypotenuse?
Yeah, it's always the hypotenuse.
Where are we?
I just wrote this at the top.
Oh, yes.
But like I said, the opposite and the adjacent sides always change depending on what angle you use. So if we take this triangle ABC, we know that the slanted side is hypotenuse, okay? What angle do you guys want to use, A or B? We'll use angle A. So if we're using angle A, across from angle A is side CB. This is going to be the opposite side. The adjacent side is the side that is beside the angle. So the adjacent side is AC. So adjacent just means beside.
Oh, so it doesn't matter which one you do. Yeah, it does.
It matters because the opposite and adjacents change.
But they'll always give you one angle, right?
Yeah, I'll always give you one angle.
I can't. Triangle.
So hypotenuse is always a slanted side, like I said. Your opposite is the side that is across the angle, and your adjacent is the side that's beside the angle. So if I draw that same triangle and I use angle B, so let me draw that same triangle. So let's say I have A, B, C. So if I use
The C angle, the B angle would be the opposite.
Yep. Yep. So if I use my angle B, my hypotenuse stays the hypotenuse because it's always the slanted side. But which side is my opposite side now? Which is, Jade? Yep. So this is going to be my opposite side now. And my adjacent side is going to be C and B. So again, depending on what angle you are using, your opposite and adjacents might be different. So are we good so far with this?
Yeah.
Okay. So like I said, the hypotenuse is always the side. It's always a slanted side. The opposite side is whatever is across from the angle, and the adjacent side is the side that's directly beside the angle we are referring to. So your vertices are labeled with capital letters, and then your sides are labeled in lowercase letters. So we already discussed this. We said sine A is equal to opposite side divided by the hypotenuse. Cosine, we said, is the adjacent side divided by the hypotenuse. And tan is the opposite side divided by the adjacent side. And this letter after the whatever sine, cosine, or tangent, what do you think that letter represents? Cynthia? Yeah, the angle. So if it's asking for sine A, I'm looking at angle A. So sine A is equal to opposite over adjacent. So I'm going to find angle A, and then I'm going to label what's my opposite, what's my adjacent, and what's my hypotenuse. So for the first triangle, we have write the ratios for sine A, cos A, and tan A using the following triangle. So we have sine A. So what angle are we going to be using? Which angle? Angle A. So angle A, so this is going to be known as our angle of reference whenever we're referring to a specific angle. So which one's my hypotenuse side? 5. So 5 is hype. What's my opposite side? 4. And my adjacent side is obviously 3. So sine A is equal to opposite over hypotenuse. So we know my opposite side measures 4 and my hypotenuse is 5. So we can just say that sine A is equal to 4 over 5. Can someone tell me what cosine of A is? 5 over 3. So adjacent over hypotenuse. Well, yeah, no, it should be 3 over 5, yeah. Adjacent is 3, hypotenuse is 5. So cos A is equal to 3 over 5. And then who can tell me what tan A is going to give me? 4 over 3. Opposite over adjacent, which is equal to tan A is equal to 4 over 3. Okay, simple enough. Now the next two is just using your calculator. So what you're going to do for the next one is using your calculator. You want to find the trig ratio for each of these degrees. So we run around it to the nearest thousandth, which means to 3 decimal places. So we're given the angle, right? We're not given a triangle. So in this case, all you're gonna do on your calculator, depending on which one you have, some of you have one like mine, so you'll find the sign button, press sign, then enter the number 50, and press equals, and it should give you a decimal. For some of you, you might have to enter the number first and then press sign.
I did not get that. So three decimal.
3 decimal. 0.766.
Yeah. Would you round that to 7? 2 6.
Third decimal place, so 66. On your calculator, Emma, at the top, does it say degrees or does it say something else? Yeah, you have to change it.
That means.
So make sure your calculator's in degrees. On the top part of your calculator, it should say DEG or RAD or something else.
How did you fix it?
You just have to change the mode. You just press second, DRG, and then just press 1.
And then
So
what?
now try sine 50 now. It should give you 0.766.
0.766. I got it.
Okay, next one, tan 63. What did you guys get? Read it. We did tan of 63 now.
Yeah, 63. 1.9.
Yes, what'd you get? Oh, 63, right, rounding up, sure. It's 1.9626, so it should be 1.963. Brooklyn, what's the last one? Cos 89? 0.017. Do you guys remember how to find angles on your calculator?
No.
No? So with the calculator, what you're gonna do, so I'm gonna put the steps on calc. So to find angle, so 1 press second function, and then press sin, cos, or tan, enter decimal, or fraction, because sometimes you might get a fraction. So for the first one, you have tan of 1.782. So to find that angle, you're gonna have to press that second function with the tan to the -1, and then 1.782.
Sorry, could you go back to the steps? Yeah. Okay, second one.
Second function,
And then
press sine, tan, or cos, and then enter the decimal or fraction.
You need to put the number in like bracket.
Yeah, so once you press second function and hit tan, cosine, or tan, it's gonna give you a bracket and you're gonna put the number in it. Does it give you something to put after? Yeah, then just enter the number. So we're gonna round to the nearest degree. So Ashton, what'd you get? 60.7. So 61.
So,
Yep.
what's the second one?
Inverse. That's it.
So how would you write this? Tan A equals 61.
You write angle A. So whenever you're finding the angle, you're gonna write. So whenever you're finding the angle, you're writing angle A is equal to tan inverse of the decimal, because when you find the second function, it says tan -1. And then you're going to write your angle as angle A is equal to 61 degrees. And you're doing the same thing with the other ones.
61.
When it was on M before.
You press that one, like, do you have this button? Look, I don't know if that's.
Well, yeah, here's just the
Oh, yes, it is. Oh, thank you.
It
gave me for me 30.5. It's just that
31. So what did you guys get for the next one for B? 31? So if it's 30.5, round up to 31. And then the last one, cos C is equal to 0.895. Pardon? 26? Is that what we all got? Yep.
How do you make the decimal and the degree?
So you have to press the second function on your calculator and then press sine, cosine, or tan, whatever is asking for, and then enter the decimal and press equals. Or some calculators, you have to enter the decimal first and then press second function and the trig ratio.
Let's go for X.
It's not.
I don't remember that. Do you remember that? Oh, yeah.
Yours is shift.
I don't remember any. I never.
Okay. So mainly you're going to be using a calculator. Huh? Yeah. All right, so the next one. So for example, 4, you want to solve for x, okay? So this is when you want to find your side lengths, is when you're solving for x. So I have sine of 65 degrees is equal to x divided by 7. So I need to leave x by itself. How do I get rid of the 7 over here? Yep. So you multiply both sides by 7.
How do we multiply this into 5? So would it be this?
You said it exactly how it's supposed to be done.
You multiply both sides by 7. So it would be like sin 65 degrees times 7?
Yep.
Okay.
That's it. So you're going to get 7 times sine of 65 is equal to x. Okay, so when you do 7 times sine 65, remember we're rounding it to the nearest tenth, so the first decimal place. What's 7 times sine 65? So x is equal to 6.3. Pardon?
I got 6.34.
You literally just do 7 times sine 65 or whatever.
So you don't do it like that, you do it like, you have to do sine 65. Oh, wait.
Yeah, so on this side it gets canceled out. That's where you're left with x by itself.
We have to show that we're multiplying 7 as well.
So this is what you do when you have your variable on the numerator, is you have to multiply both sides by whatever the denominator is. So the next one, your variable is at the bottom.
Yeah.
Okay, so when it's at the bottom, all you're doing is you're switching places with the trig ratio and the variable. So your x is going to come to the top, and then tan 34 is going to come to the bottom. So you're going to get x is equal to 21 divided by tan 34. So all they're doing is switching places. That's when your variable's at the bottom. And then with your calculator, you're going to do exactly how it looks like. Do 21 and divide that by tan of 34.
And this changed because the 21 was like on top.
Yep.
4, 31.
What?
Did I get that right?
31 point what?
1.
21 divided by.
So Cynthia, yours would be 21 divided by 3410.
Yeah, I did that and I got 0.67.
Are you on the right one?
Just getting this calculator.
Are you on rad?
No, she's on degrees.
Oh. What does rad even mean?
Radians. So instead of writing 45 degrees, you would write it as pi over 4. And instead of 90 degrees, you write it as pi over 2.
Okay, I have to press 31.1. Okay, that's it.
So easy so far? So for example 5, I want to find the side lengths. Yes.
How do I find the side lengths from following triangles?
So we're going to find the side length of the following triangles. Okay. So for for the first question in A, what side are we, or what is our missing side? What is it labeled as? X. Okay.
So we gotta do the same thing that we did before.
Yeah, but what angle is given to us? 60. So 60 is our angle of reference. Okay. So now we need to figure out what 15 and x are in reference to angle 60. So 15 is going to be what? Hypotenuse, opposite, or adjacent? Hypotenuse. Okay. Remember, we're using angle 60 as our angle of reference. What would the side where x is be? Adjacent. So if you look at Sohcahtoa, which one uses adjacent and hypotenuse? Cos.
A.
So cos A is equal to adjacent divided by hypotenuse. All right. So cos of 60, because that's our angle, is equal to our adjacent, which is x, and our hypotenuse, which is 15. So how do I get x by itself? Multiply both sides by 15. So I'm going to get 15 times cos of 60 is equal to x. So now all you do is plug that into your calculator, and you have to round it to the first decimal place. 7.5? So therefore, side x is 7.5 whatever units. So we'll say centimeters. Okay, try doing B on your own. So for question B, you have that triangle. Okay, remember 40 is your angle of reference. So try to do B on your own. And I'll keep this up as you guys are doing B on your own. Okay, what did we get for B?
The same way.
Who can tell me what they did? What did you do?
Yay.
Mhm. So x is opposite and 19 is hypotenuse based off our angle of 40 degrees. Mhm. Yep. Perfect. You get 12.2, right? All right. So that's that. Everyone got 12.2? We're all good? Perfect. So now we're going to be talking about angles of elevation and angles of depression. So the angle of elevation is where your hypotenuse and the bottom side of the triangle meets. So this is your hypotenuse. This is your ground or the base of the triangle. So this guy over here is your angle of elevation.
Wait, what's the other one? The bottom one?
So that's the base of the triangle.
Oh.
So this is going to be your hypotenuse, and this is going to be your base of triangle. Now your angle of depression is when you're looking down at something. Yep. So your angle of depression, so this is you at the top. You're looking horizontally onto the horizon of the sky. And your angle of depression is when you look down at a certain object. So it's not actually, if we make a triangle here, your angle of depression is not exactly inside of that regular triangle, it's on the outside. So the angle of elevation is the angle made between the horizontal or the base of the triangle and the hypotenuse. The angle of depression is the angle made between the horizontal when you're looking straight horizontally towards the object and to the hypotenuse of the triangle. So this is a word problem, so you're gonna have to draw the diagram. So whenever you're given a word problem now, you guys are gonna have to draw the diagram of the actual triangle. So you will be getting marks for drawing it properly. So for example, you're on a field flying a kite. You have let out 150 meters of your kite string. Estimate that the height of that the kite is at an angle of elevation from you of about 20 degrees. Can you calculate the height of the kite above the ground? So what type of triangle are we going to be drawing regardless?
I have half a triangle drawn.
So is it going to be a right angle triangle, a random triangle? What are we drawing? We're drawing a right angle triangle. Remember, because this unit involves right angle triangles. So you have your kite over here. Okay.
What is this?
It's a kite.
Oh.
So this is the string of the kite. Okay. This is Cynthia holding the kite.
Yeah.
Why does she fall? You have your hair.
Look how short your hair is. You need longer hair.
Math is fun. Okay, so this is the string of her kite. And then, like we were saying, we're making, of course, a right angle triangle. So what information are we given in the question to help us solve for this problem? Can someone tell me where I'm going to label what? Olivia?
Like the size or the angle?
Where's my angle going to go? So it's going to be here. So this is my angle of elevation, which is 20 degrees. What else do I have, Brooklyn? Where is that going to be labeled? Okay, and Ashton, what are we finding? What does it say in the question? What are we finding? The height. So what part of the triangle is going to be the height? Yeah. So we basically labeled everything. So remember, we're using 20 degrees as our angle of reference. We agreed that x is our opposite because it's across from it. And 150 is our hypotenuse. So what has opposite and hypotenuse? Sine. So we're going to do sine A is equal to opposite over hypotenuse. We know my angle is 20 degrees. So the opposite is x and my hypotenuse is 150. How do I leave x by itself? Cynthia? Yeah, multiply both sides by 150. Yep. So remember, we're rounding it to the nearest meter. So you're just taking your calculator and doing 150 times sine of 20. So round it to the nearest whole number.
51.
So everyone got 51.3? Therefore, x is just 51. So my therefore statement is therefore the height of the kite is 51 meters. So one thing that you guys have to understand is you can always tell when you're wrong, okay? The reason why is because the hypotenuse is supposed to be the longest side. If, when you're solving for opposite or adjacent, if you ever get that number bigger than your hypotenuse, then you did something wrong. Okay, your hypotenuse always has to be the biggest number. So you can tell right away if your number was bigger than the hypotenuse, then you probably did something wrong. So I'm going to post the homework schedule on the board. I think that was it. Yes, that's it.
Oh, wait, you were right.
I'm going to post the homework schedule on the board, on Google Classroom, and you guys are going to get started on the first section of homework.